Hello everyone, welcome to my YouTube channel Suprita Care. I am Suprita Care, currently pursuing in BE in Sri Venkateshwara College of Engineering of the branch Artificial Intelligence. I am studying in a first semester in the section of DEVO. My library number is 23CA1686 and the course title is Applied Physics for CSE stream and the course code is BPHYS102. And today I am gonna make a video about applications of a fiber optic networking and communication. Let us see what is a fiber optic communication and a networking. The fiber optic networking is made up of a cables containing a bundle of glass or a plastic strands called optic fibers, which carry a data that has been transformed into a light. The light is transmitted along the fiber optic network by a laser after having been converted by a computer into a digital data signals. Types of optic fiber networking. There are two types in a fiber optic networking. One is a single mode fiber optic networking and the second one is a multi-mode fiber optic networking. Now we will discuss about a single mode fiber optic networking. A single mode fiber optic cable features a small core that only allows one mode to be transmitted. This means the number of reflections decreases as the signal moves within the core, which lowers the attenuation. This feature enables the signal to transmit at a greater distance and a faster speeds. You can observe in the diagram there is a core and a cladding diameter. The cladding diameter is of a 125 micron and the core diameter is of a 62.5 micron. Now we'll discuss about multi-mode fiber optic networking. Multi-mode fiber allows a large number of modes. The light ray traveling through it. The core diameter is generally about a 40 micrometer and the cladding is of 70 micrometer. The refractive index difference is also greater than the single mode fiber. There is a signal degradation due to a multi-mode dispersion, which allows a more number of reflections. There are two types of a multi-mode optic fibers, and one is a step index multi-mode and a graded index multi-mode, and the diameter of a core and a cladding are both same in these step index and a grade index multi-mode. Now we'll discuss about applications of a fiber optic networking. First one is long distance communication. That is, optic fiber is ideal for a long distance communication because light travels through it with less attenuation than the electric wire. And the second is computer networking. Fiber optics can transmit a data and provide a high bandwidth internet. Fiber optic cables can transmit a large amount of data over a long distances, and today it is very needed in these generations, through which and fiber optic networking is making a possible. And fourth one is optical switches. Optical switches route optical signals from one fiber to another. Biosensors. Optical fibers are used in optical chemical sensors and optical biosensors. And the last one is the data cabling. Fiber optic cabling can carry more data than the copper wire. And this is about a fiber optic networking. Now let's discuss about a fiber optic communication. What is fiber optic communication? It is a method of transmitting a data using a light instead of electricity. It uses optical fibers to transmit information. Optical fibers are very thin, flexible, transparent fibers made up of a silica or a glass or a plastic, which is flexible, which can easily bend in every shape, and the transparent and which are very thin. In fiber optic communication, infrared or visible light pulses are sent through an optical fibers. The light is a carrier wave that is modulated to carry information. Fiber optic communication has the following characteristics, which has a very low attenuation, which has a very high bandwidth and a small in size, which can be carried and elaborate in a very elaborated size, and a low weight, which can be easily carryable to every places, and no electromagnetic interference. Now we'll see the flowchart of the optic fiber communication, and here is the flowchart. The electrical input is received by a transmitter, and this transmitter is going about optical fiber, and this optical fiber is going through a receiver, and the output is received as same as electrical input. We'll see a detailed information of this flowchart working. It consists of a transmitting fibers coupled by a laser source and consists of a receiving fibers coupled to the detector. There are a number of fiber optic bundles which are laser as a source, and the receiving fibers which are detector which detects the communication. In the communication, the analog information such as a voice of a telephone coming out of the transmitter section of the telephone are fed to the coder, which means this is the external communication which is fed through the telephone or unfit which is fed through the coder. The coder converts analog information to binary information which comes out as electrical pulses, and these electrical pulses are fed to the optical transmitters which convert the signals into the optical fibers. You can see in the diagram the transmitter which consists of an electrical fiber networking, and these electrical fiber optical pulses are fed to the fiber, and the acceptance angles propagate within the fiber by means of total internal reflection. This works as a principle of a total internal reflection. The photodetector converts optical signals into electrical pulse in the binary form, and the decoder converts the binary data into analog signal which will be the same as info such as a voice. And this is the flowchart of an fiber optic communication which transmits information from the from the electricity. So this is about a fiber optic communication and the networking. Thank you for listening, and please share, like and subscribe to my video.